Let's consider another numerical problem related to the phenomenon of photoelectric effect. The question is saying that threshold frequency nu naught for a metal is 7.0 into 10 to the power 14 per second. This is the threshold frequency, the minimum frequency required, the minimum frequency with which light will be able, or an electromagnetic radiation will be able to eject an electron to eject an electron from the metal. That means so that photoelectric effect takes place. Calculate the kinetic energy of an electron emitted when radiation of frequency nu is equal to 1.0 into 10 to the power 15 per second. But now this is the threshold frequency, but you are hitting the metal with a light having this much frequency. You're hitting the metal with the light having this much frequency. So what will be the kinetic energy of the electron? According to Einstein's equation, which explains the photoelectric effect, because of which he got the Nobel Prize of Physics, the Nobel Prize in Physics, is that the energy that comes out from a source of electromagnetic radiation when charges when a body with electric charge accelerates, it radiates electromagnetic radiation, which comes in the form of packet. That means comes in the form of quantum. Not it's The energy doesn't come continuously. It comes in packets called quantum or photon. The energy of one photon will be used to eject one electron from the metal. So this is the concept, and some part of energy will be required to just remove the electron, and the remaining energy of the photon will utilize, which will be seen as the kinetic energy of the electron. So whatever energy falls on whatever the energy that is possessed by one photon will be utilized to remove an electron, that is for which a minimum frequency is required, and the remaining energy will be manifested in the form of kinetic energy of the electron. So if we want to calculate the kinetic energy, what we need to do is we need to subtract the work function, the minimum energy required, from the total energy of the photon. Total energy of the photon is written as h into nu, h into Planck's constant multiplied by the frequency of the light or electromagnetic radiation that they are using, minus Planck's constant into the minimum frequency needed, right? So in these two terms, Planck's constant is common. We take it out. So what remains is the frequency of the light that they're using minus the threshold frequency. The value of Planck's constant is 6.626 into 10 to the power minus 34 joules second. And what remains inside is 1 into 10 to the power 15 minus 7.0 into 10 to the power 14. To make it 10 to the power minus 15, it will become 0.7. 1 minus 0.7 is 0.3 into 10 to the power 15. So minus 34 plus 15 becomes 10 to the power minus 19, and 6.6 multiplied by 0.3 becomes 1.9878. Since there are two significant figures, we can round this off to 2.0 into 10 to the power minus 19 joules will be the kinetic energy of the electron. And if we know the mass of the electron, then from this kinetic energy, which is half mv square, we can calculate the velocity of the electron as well. I hope it's clear.